Okay, in this segment today, we are going to build a compass. These are some things that you need. You need 10 ring magnets, you need a screen, you need a magnet probe, and you need a pencil. Okay, let's get started. First thing I need to do, I need to find the middle of the pencil so I can balance it. And by doing this, I'm going to use my finger. Okay, this is the middle of the pencil. The next thing I need to do, I need to put this screen in the middle. So the middle of this pencil is in between the words highest and test. So I'm gonna mark it right here with my thumb. I'm gonna grab the screen. I'm gonna tie it in the center of it, like so. I want to make sure it's tied pretty good because it's gonna be balancing out these magnets. All right, sit right there. Next, I have to put 5 magnets on each side of it. So what I'm gonna do is, I'm gonna separate these magnets I have here in 5. I'm gonna count them out to you. 1, 2, 3, 4, 5. These 5 are going to go on this side of it, and these 5 are going on this side. Now I need to move this magnet probe out the way because it attracts to magnets. So I need to push it out the way. Okay, I'm gonna take off each one of these magnets one by one from each side. Put one here. One. Take this one off. Put this on this side. See how the magnets are attracted to one another. Put another one here. 2. 2. And you can always slide it back toward the middle once you put them on here. 3. 3. Almost finished with this part of it. 4. 4. 5. 5. All right. Now the next direction is, I have to turn the pencil 90 degrees and check to see if it returns to the original direction. If it does, turn it 90 degrees in the other direction to ensure it works properly. If it begins to spin quickly, stop it and then let it go again until it is steady. Okay, I'm gonna pick this up by the screen. Now I'm gonna have it in this direction here. Now that is pretty much balanced out here. All right, but I'm gonna turn it to see if it's gonna go back in its original direction. Okay, it's pretty much going back in the same direction. It might be moving a little, but it's pretty much going back in the same direction that I had it turning. Okay, we're gonna stop it here. Okay, keeping the pencil steady and above a specific point, slowly walk around it, keeping it in the center of your walk. Imagine that the pencil is the center of a wheel and you are the tire. This may help you visualize how to walk around it. Okay, I'm gonna stand up and I'm gonna walk around with it. I'm gonna keep it center, position center in my body. I'm gonna walk around like this. Remember, we're making a compass. Stop it. According to number 4, it said if you are doing it properly, the magnet and the pencil should remain pointed in the same direction. Can you determine which side of the magnet is north? What do we know about magnets and which side they are attracted to? Which side of the magnet points north? Check your answers using the magnoprobe. This is the magnoprobe here. All right, let me flip like it says number 7. It says remove 2 magnets at a time from your pencil, but we haven't come to that yet. So we're going to turn back here. It says the magnoprobe is a highly sensitive indicator used to study 3-dimensional magnetic force fields. The red side of the probe indicates the North Pole, and the blue points to the south of the magnet. Since the magnoprobe is free to rotate on 3 different axles, you can see where the magnoprobe is force exerted. Okay, so it's saying right here that the red side of this indicate the north, and the blue side indicate the south. Okay. So if that's the case, the way it's turning now, the pencil is turned toward the north. Making your own magnetic pole, and you have your own very compass.
Okay, good afternoon. Hello, everybody. We're going to do this particular experiment measuring the strength of magnets. And so the parts that we have here, we have 4 of these jumbo magnets. We've got 2 plastic cups. We've got some craft sticks here. We also have 10 washers, and we have a jumbo paper clip. But for this particular experiment, we're going to use a medium-sized paper clip because of how we're set up here. And so the first thing we want to do is we're going to take our plastic cups. We're going to have them face down. Once we put them face down, so that we can make sure that it's on this flat surface. And then the next thing we're going to do, we're going to take our craft stick and we're going to place it on top of both of the plastic cups so that it can form a bridge. Okay? So now that we've got our bridge, we're off to a good start. So the first thing we're going to do is we're going to take our magnet and we're going to put it in the middle of the craft stick so that it would be right in the middle so that we can have a balance between the 2 cups. After that, we're going to take our paper clip, the one that's slightly already bent so it'll look like a hook, so that we can put it under the stick, under the magnet, so that the force of the bar magnet can take the paper clip and suspend it here in the air. All right, very cool, very cool. All right, so I think what we'll do is we'll do it this way so the hook is a little bit larger. How about that? Okay, and so now, so if you put it on the small part, you see what happens. It'll go straight up because it's a little bit too light. So let's go ahead and use the larger hook, and now it's suspended here in the air. So now what we want to do is, because we're trying to create data to see how many washers will this particular paper clip hold while it is suspended in the air. Okay, so you can use the big sticks that we have here, craft stick, or you can also use the smaller ones for different experiments, just to get a feel of which one might be best for you. And so now we're going to go ahead and take our first washer, and you see what happened. So we have a magnetic field that happened when we got our washer close put it on here. How about that? How about this? We just put it on and stick it back up there. How about that? Because that's easiest for us. Okay, so we have one. Oh, so at that end, it only was able to hold 2 washers. But how about this? Let's add another, add another paper clip. You see how powerful these magnets are. So let's try 2 magnets and see what happens. And again, it's going to take you some time to kind of find your way with this particular experiment, but it's so fun seeing how all of the magnetic fields come together. All right. So let's try it this way. We've got 2, a little bit stronger. All right, let's try this. 2 magnets, 2 washers. How about that? All righty. I think we're doing good. Let's try another one. Not so much. So hopefully you got an idea of how it's supposed to go. Again, we have our paper clips here. Let's try a larger paper clip. I think that might be cool. All right. Let's give it a little extra boost here. All right. It's too long. The paper clip. Our jumbo paper clips are too long. So, wait a minute. Aha! There we go. All right, let's try washer number 3. We're getting more washers here. Okay, how about this? See if we can have it hang down. How about that? Aha! We're doing good. Okay. So hopefully you get the idea and you'll be better at this than I am. But this is our experiment measuring the strength of magnets. Have a good day.